and thank you to the sponsors as well, because your group really does do important things, and it's good to know. So thanks for coming, and thanks to Josh and Brandy for putting this together, for inviting me and arranging. And here's a penguin if you like penguins. So for what it's worth, and here's another penguin. Right? So ultimately, I bet every one of you comes from a university that has a sustainability institute or a sustainability initiative. I was talking to the United Nations dinner last night. The United Nations has sustainability goals. How do we live so we can live well? And so our grandkids and their grandkids and the penguins can live well too. And really, I know there's 100 academic definitions of sustainability, but that's really what this is about, right? How do we live well, and so our grandkids and their grandkids can live well? And that's really why we're here. If we had more time, or if you could come take a class that we teach here, we'd walk over a little bit. You have up here somewhere, what about carrying capacity? Right? The world 10,000 years ago was overpopulated. And it's pretty clear that it was. When people came into the Americas, they looked around, and it was mammoths and mastodons. I mean, it was steak on the hoof. And they promptly set about killing them off. And they were helped by climate change, but those mammoths and mastodons had lived through a whole heck of a lot of climate changes without dying. And as soon as a fluted point spear showed up in a rib cage, they died. And across the world, people were killing things off 10,000, 15,000 years ago, probably when the population of the world was a few million. Maybe tens of millions, probably millions. We were overpopulated. There's a study came out this week in the Proceedings of the National Academy of Sciences that looked at a history of hunter-gatherers in California. When the drought hit, they killed each other. And that's what our ancestors were doing. And they learned how to do agriculture. And they learned how to clean up after themselves and get along and not poop in their own drinking water. And we took a world that was overpopulated at a few million, and we turned it into a few billion. And we will meet people who are not impressed with learning and teaching. These people are living in fantasy la la land. Our ability to learn and teach and build and grow and get along with each other is simply not optional. It is completely essential. And the idea that we will go back to the old ways when what we're doing now doesn't work means that the next 1,000 people you see, 999 of them have to die. And that's fact. I'm not making anything up here. It's really amazing. You know that population has been on an exponential. And if you remember about 8th grade math, that cannot continue. And you run out of standing room at some point. There is an optimistic version of that, which is that we roll the population over. People choose to replace themselves, and not more, if they have two things, right? One of them is they are confident that when they have kids, that those kids will not die as babies, they will grow up. And the other one is that they have interesting things to do with their lives and a little control over their lives. That especially applies to women, but it applies to everyone. And if people have confidence that their kids will grow up and they have something interesting to do with their lives, the population is projected to roll over to about 9 or 10 billion and stabilize. We don't get those. I don't even want to think about it. Okay, so you can think of some very bad things. But you can see a future where we stabilize things by choice. And it comes from getting good things for people. Now, we were overpopulated at a few million, and since then we've doubled the population about 10 times. Maybe 5 billion of us are sort of confident our kids will grow up and we have interesting things to do. So one more doubling. We've doubled 10, we need to get to 11. One more doubling potentially will do it. The difficulty, of course, is that we are doing, the 5 billion of us that are doing pretty well are busily using things that nature is not replacing. And so a lot of what we're doing to get by now is sustainable. And how we double once more while filling in those holes of what we're doing that we can't keep doing is the real challenge. The United Nations said, look, it's food, soil erosion, phosphorus for fertilizer, biodiversity, there's a bunch of issues. Probably the biggest one, though, is energy. Of all of the issues of sustainability, probably energy is the single biggest. That does not mean that the others are small. It means that that is probably the single biggest. And so I'm going to walk you through the energy, but first I'm going to just step aside for a moment. I live up here in the ethereal, you're down in the doing useful things. And I just want to, I don't have the answers. I used to get on the plane and go to Greenland, you know, and I've learned a lot and I hope it's useful, but you're the people that are doing what matters. I have had fun, right? I've gone to Greenland. Some of you have seen this picture. I've shown it more than once. At the time I took this picture, I'd been in Greenland a month. And when you've been in Greenland a month, the newspaper over here on the side actually was a month old. It was perfectly functional. This is a good day in Greenland, this is a bad day in Greenland down here, right? So that's, right, it's fun sometimes, right? And I will come back to why I showed these a little bit later. But this is me without the shirt, and that's Joan Fitzpatrick, and we're digging holes, and we're looking at the layers in the snow, and we're making climate histories. And so I used to do that. And when I did that, in the old days, there were days, there were weeks that our radio didn't work, and if something had gone wrong, we'd have been in trouble. And now, you know, so there's Bruce Tosi trying to get radio out, and it wasn't working very well. Now you know what communications are like. And this is not directly related to what we're about to do, but it is. Right, I was down at the Delta program last Wednesday talking to the middle school. And it is a fascinating thing to do. Go into a schoolroom, especially sort of 5th grade or something, and pull out your cell phone and ask them, what's it made of? Right? And you'll get that silence you get for a moment from students. And then if it's a 5th grade class, some very bright student will say, cell phone parts. And you say, what's a cell phone part made of? What's it made of? It's a little bit of sand for the glass and the silicon and the chip. And it's a little bit of organic matter, probably oil for the plastic. And it's the right rocks, the ones with the gold and the copper and the rare earth elements. And that's all it is sand, oil, and rocks. And science and engineering and a little design and marketing. And, you know, Einstein is in here. The GPS is just a fantastically accurate clock. And it is perturbed enough by the gravity of the Earth that you actually do have to use relativity in the calculations or it will get lost. And quantum mechanics is in the computer. The most esoteric, impractical, unbelievably bizarre physics of the world, relativity and quantum mechanics, is in your pocket working for you every day. Right? It's a fantastic thing. And you have a whole bunch of neighbors and a few students who will pull this thing out and will send an email or a tweet that says scientists have no idea what they're talking about. I'm sorry, it's really, but if you want a good news, it is that you can turn sand, oil, and rocks into access to more information than what's in all the libraries of the world when we were students. And that's really good news. Right? Now this thing is powered. You go to an airport and watch how many people are wandering around trying to find power for this. Where's the plug? I gotta find one. Okay. You're headed for lunch in a minute. Right? In these units, the food you burn inside you generates about 100 watts average day and night, summer and winter. Your heat output, your energy output is the same as one old light bulb. Right? All the good you do, all the brilliance that you bring is one light bulb worth, which is sort of amazing if you think about it. But you don't spend the summer hoeing, and very few of you probably walked here. Most of you probably drove. And, you know, I would bet that you didn't have to ride a bicycle to run a generator to power the microwave to cook lunch. Something did that for you. The energy use in the U.S. economy in these units for you is more than 10,000 watts. What you can do for yourself is 100, and what is done for you is 10,000. Different units, they usually calculate what we eat in 2,000 calories per person per day. I had one of those little rolls over there. I probably shouldn't. I'll try to keep it to 2. But what's done for us in these units is a little more than 200,000 per person per day. And right now it's about 84% fossil fuels. Right? And that's unsustainable. It has to end. And that is a worry because we love this. It's a great thing. But it has to end. You have come to Penn State. If you have a chance, if you walk down the hill, you will get to State College. State College is a suburb of Penn State. When Penn State was founded, there was no State College. It did not exist. When Penn State was founded, it was founded up the hill from the iron furnace. And you can see it down the hill here on your way out of town. And now it looks like this. You can see the sign for Penn State, and you can see this little thing. When it was running, it probably looked more like this. This is actually a well furnace. But they were turning red dirt and limestone flux into the iron that built the East. And you're here ultimately because of that. And it was powered by charcoal. And they cut trees, and they made these giant piles, and they buried them in dirt, and they burned them with restricted oxygen to drive off the water and some other things and leave something that would give a hotter flame. And if the dirt broke, you'd have to climb up and try to patch it and not fall through. But this is what it did to the land surface. A furnace in blast took the trees from more than half a square mile. And there may have been 100 people taking care of that furnace. And they had houses, and they cooked, and they heated. So a furnace in blast, figure a square mile of trees. And after you've cut those trees and burned them, it's 30 to 50 years before you can do it again. A square mile for a furnace. On your left, if you go to a map of Pennsylvania and ask, where do we remember the name furnace on the map? These are still on the map. Now there's a bunch more furnaces that aren't on the map anymore, but they're still out there. And these are forges, the Valley Forge, so you take the iron and you make it into valuable things. Every line on here, plus a bunch more when it was working, was a square mile of trees a year. And they were gone. The first, right, this is Penn's Woods. When William Penn came here, they said that a squirrel could go up a tree at the Atlantic coast and stay in a tree to the Mississippi. The first forester of the Commonwealth was Rothrock. Rothrock wrote about the Pennsylvania desert. Now, it wasn't a desert, but the trees were gone. There wasn't anything to burn. We have 1 million deer in Pennsylvania now. There were essentially none left. We have elk because we re-imported them from the Rocky Mountains. We chased them out. We chased out the bison. We're the Nittany lions. There's no Nittany lions. There wasn't a deer to eat, and there wasn't a tree to do it by. Basically, anything bigger than a squirrel or a rabbit, we chased it out of Pennsylvania because we burned all the trees. Now, if you've ever tried to read by firelight, it's very hard. And so what do? You burn whales. Sometimes they did some biofuels and some other things, but a lot of them burned whales. And we sent Yankee whalers out to scour the world ocean for whales and cook them and send the whale oil home so that we could burn it so we could see in the evening. People were spending over 20 bucks a gallon for whale oil so they could see at night. And we burned basically all the whales that the Yankee whalers could catch. And it took 100 years after we quit burning whales before they grew back. And we have whales in trees because of that. And coal. And we really do. Right? And they knew it way back then. So if you can't read this at the bottom, this was published in the magazine Vanity Fair in the year 1861. And the caption reads, "This is the grand ball given by the whales in honor of the discovery of the oil wells in Pennsylvania." Okay, so this is right before the Civil War, so it says, "The oil wells of our native land, may they never secede. Oil's well that ends well, we wail no more for our blubber." We have this history. We want somebody else to do our work for us. And we get that by burning something, and we burn it way faster than nature makes more, and then we run out, and then we hit a crisis, and then we look for something else to burn. And we burn the trees. Late 60s, when the Pilgrims got to Cape Cod, it was goodly wooded to the shore. By the late 1600s, the town of Eastham passed a law, you may not cut your own tree on your own land, because the trees were basically gone, and the deforestation was so extreme that the government got in your face because they were in crisis. In the 1600s, our freedom-loving ancestors are already in crisis. How much fossil fuel we burn is just flabbergasting. Right? So you can get a feel for this. You know what trash looks like. A lot of you are working on recycling to keep it down. But if you've ever taken the trash out to the curb, or you've ever been caught behind the trash truck, in round numbers in America, on average, we throw away at the curb for the trash collector a half a ton per person per year. But all of those coal trains, when you burn it, makes CO2 that doesn't disappear, it goes in the air. And all of that oil, all of that fracked gas, makes CO2 that doesn't disappear, it's there. Half a ton of trash to 20 tons of CO2. If we could see it, we wouldn't even be having this discussion. It's a fantastic amount. I was asked by a reporter fairly recently, is it true that global warming was invented by the Chinese to destroy the American economy? I said, well, the first calculation of what burning coal and the CO2 would do to the temperature of the globe was done by Arrhenius, who was a Swedish chemist, in the year 1896, before Einstein and before quantum mechanics. So if that was a Chinese plot, it was a remarkably prescient one. We knew a long time ago about this. What we didn't know was 20 tons, how good the fossil fuel companies would be at giving us what we asked for. The quantum version, right? So Arrhenius knew CO2 makes it warmer. The quantum understanding, the really getting the physics right, was worked out by the Air Force right after World War II, and they were doing heat-seeking missile sensors. If you're trying to shoot down an enemy bomber, the engine is hot, it emits infrared radiation, you can follow their tailpipe and make sure they don't blow up your big city. And if you put the wrong sensor on, CO2 absorbs that radiation, the molecule collides with oxygen or nitrogen, and there's just a faint glow rather than a target. Even on a cool day like this, the sun is heating the earth, it is sending infrared to space, CO2 is absorbing it, it's colliding with other molecules, and is warming the atmosphere. And we add 20 tons per person per year to the atmosphere, and it makes it warmer. There's nothing to believe, it's just physics. Now, there's a huge, I teach one of the classes, and you know, there's a huge amount of information on this. One little piece of that information is the history of climate. Like I say, I used to go to Greenland, and we still do work on paleoclimate. You will meet people routinely who say climate has always changed. Yes, And nature has always made fires, but arson exists. And an arson investigator had better know what a natural fire looks like. I spent a lot of my career learning about natural climate change. What have we learned? Lots of things change the climate. CO2 changes it more than anything else. We recognize climate changes in part by what they did to living things. They have huge impacts. We're changing CO2 now in ways that are bigger and faster than what nature did. And the history has big impacts. And so yes, climate always changed. And we keep doing what we're doing, and we frack it all, and we take off all the mountaintops, we will be huge compared to all of geologic history. And our look at the history confirms the physics. And we see this kind of stuff. I mean, this is just a picture out the window on the way to Greenland. This is in Greenland. But all you need is about that much. That's ice, and that's where it used to be. And where is the ice now? Well, it's in the ocean. And you look at a picture like that and you say even a little bit of extra water in the ocean can be a bad thing sometimes. But we might drive sea level out of the picture up. And that could be really bad, not just for New Orleans, but for a whole lot of coasts. And then we come to this one, right? Suppose we decided that we're going to quit burning things far faster than nature makes new. And we're going to do what our ancestors did when they got off of hunter-gathering and they went to farming, and we're going to farm energy. Suppose we decided to farm energy. Could we do it? So here's two numbers. This is averaged over the globe what we now use as humans, 0.035 watts per square meter. This is averaged over the globe what the sun supplies, 240. If those numbers were similar, we have a problem. If those numbers are different, we're okay. All right, those numbers are really, really different. That's good news. Okay, so just a couple of things. I am not going to get into the how you do it, just sort of the big view, because I'm not the practical guy, I'm the big view guy. But Abe Lincoln, before he's elected president, is out saying we need learning. We need engineers, we need inventors, we need patents. Abe Lincoln is the only president who ever held a patent for his own invention. And he says, you know, the wind, we need wind. We need to harness the wind and tame it and use it to help people. And so if you go to the plains now, what do you see? Here's a picture of a ranch. 5% of that ranch is put into wind turbines. 95% of that ranch is doing what it always did. But the wind turbines are a lot easier and they tend to pay a lot better. They call it mailbox money. You go out to the mailbox and you get money out of it. Right? $5,000 per turbine per year is a typical number. And that pays a whole lot better than one of those does. Right? If we built a wind farm on the windy parts of the plains and deserts of the world, that is 5 times human energy use. Just the windy parts of the plains and deserts of the world. And that hasn't even gotten into putting solar cells over the parking lot. So you plug in your car and it isn't hot after the day, but it is charged. Right? I helped the United Nations, the Intergovernmental Panel on Climate Change, along with a whole bunch of other people. They have had 5 reports spread over 25 years. They have put out about, if you published it in books, it's about that much stuff. If you tried to boil that down to one soundbite, you'd fail. But it might be that there is a social cost of carbon. We buy fossil fuels and the price reflects the good that we get from them. The price does not reflect the bad they do through the climate. And that price is real, and it's fairly high. We can talk about the social cost of carbon until we're blue in the face. We can change the words and say that's society subsidizing fossil fuels. On a scale of panic about global warming to do nothing about global warming, we're over here on make it go faster. There's a bunch of other stuff. The International Monetary Fund has looked at this and said governments are spending 8% of their receipts on subsidizing fossil fuels right The U.S. is in on this too. So we can look at it that way. You could also look at that as the profit to be made if we're smart. We're hurting society now. We can do better. And that's where it gets fantastic. Our whole history, we learned to farm food, but we've still been hunter-gatherers of energy. And we finally know how to build a sustainable energy system. And we know how to build something that really can power everyone, essentially forever. And it can be economic, and it can be ethical, and it can be environmental. And we're the first people in the history of the world that can look at each other with a straight face and say, we know how to do this. And it won't be easy, and it'll be 30 years, but most of us will probably live to see that if we get busy on it, and our students certainly will. And so let me leave you with my favorite picture. Can we have a world with icebergs and rainbows? Of course.
What your thoughts on maybe stranding resources in the ground that as we use more alternative or renewables, that makes the cost of getting it out more expensive and ultimately be stranded in the ground?
Yeah, so this issue of stranded resources, we were actually chatting about this. Through most of my career, we've always sort of looked at this and said, we know there is a huge amount of fossil fuel in the ground. There's probably enough to quadruple the CO2 concentration in the atmosphere, or maybe even octuple it. We haven't doubled it yet. It's hard stuff to get. It's tar sands, it's oil shales, it's things like that. If we burn what is monetized in the stock prices of the fossil fuel companies, we probably could hold warming to 2 degrees Celsius and we'd sort of be vaguely all right. We're getting close to the point that isn't true anymore. We may have passed it, we may not have passed it, but we're getting close to the point that things that are in the stock price of the fossil fuel companies may end up being left in the ground if we keep warming low. And that's where it starts to get hard, because then all of us have a little bit of our retirement fund in something that gets stranded. My personal belief is that is still very, very small. The stock price of Exxon probably has much more to do with their knowledge, their ability to control fuel flows, their gas stations and what have you, than it does with the value of the things in the ground, but that can change. And so the sort of giving clarity early becomes essential. Business, if you told business, look, we're going to make a 30-year transition, most of them would probably say, fine, we can deal with that. 30 years means we're going to get out of our investments, and we're the big companies, we know what to do. If some startup comes up that's going to disrupt it, we'll just buy them, and we'll be fine, right? If you tell them, we're going to make a 5-year transition, they're going to make sure you don't do it, because that's too disruptive. So my guess is that what really is needed is clarity. You need to start slow and early, and we've known that for about 30 years, and so far we have. Yes?
I have a question about methane emissions in the sort of permafrost. So I've seen some presentations that the potential carbon equivalent effect of the melting ice releasing the methane under the permafrost could actually be a game changer. And the presentation I saw said that it wasn't in the IPCC report because that requires 2 years minimum of scientific data in order for it to be considered legitimate enough, but that the actual effects, could be.
Yeah. So it is very clear that in cold places there's a lot of carbon in the soil, and in warm places there's a lot of carbon in the trees. And if we go from lots of cold places to lots of warm places, but we keep not letting the trees grow, we're going to put carbon in the air. whether we put it there as CO2 or methane is a little bit unclear yet, but we will put it there. And that's something that's not fully included in the IPCC, and it's not good news. We're cautiously optimistic that it won't be fast. It'll be long. So it's one of these that if we make it hot, we are committing to 10,000 years of hot. Delaying the transition to a sustainable energy system by a few decades to a century commits us to climate changes that will last longer than civilization has lasted. And that's pretty clear. But we're cautiously optimistic that it won't be giant methane belches that change the world. More broadly, methane is one that shows up all the time. If we really, really said we're going to hold warming to 1.5 degrees, methane is important because it is something we can get a hold of in a hurry and we can hold down a little bit. If we're trying to keep the world habitable and make it so that you don't die when you go outside in really hot places, methane is just CO2 in 10 years, don't worry about it. So the methane, whether you worry about methane or not, depends more on the question than it does on the physics. Sorry, one here, yes, and then we'll come, yeah.
So we've had 5 IPCC reports over 25 years. What's left that's important to answer? What's the one or few key questions for the IPCC to answer in the next report? Maybe can you predict that?
Yes. So the real questions, I think, and Don and I were chatting about this earlier, are down in places such as Working Group 2 or Working Group 3. So I was showing some slides last night to the UN group. People who take math tests in schools without air conditioners on hot days have lousy scores. And poor people in hot places die when it gets hot. And you have more wars when it's hot. Rapes happen on hot nights in the US. And people cuss on social media when it's hot. And so, and quantifying these sorts of things, there are efforts now that say most of the world's people, most of the world's area is in a place that all warming hurts the economy, including the rich people. And that one we sort of thought if we're rich enough it doesn't hurt us, but in fact we're on that side. So quantifying those things becomes big. The real issues probably are how we deal with this economically. As you probably know, the economists still basically assume that even if this gets bad, economic growth will be rapid. Your grandchildren will be much richer than you are. You don't want to take money from you who are poor and give it to them who are rich, so you don't want to do too much about this. You want them to fix it later. And you're more important than they are anyway. That's a pure rate of time preference, so you don't want to do much about it with that. So those sorts of issues of the ethics and the economics are really important. On the physical side, we work on the sea level rise. And we're expecting, if we burn fast and we don't change our ways, we're expecting 3 feet by the end of the century or just into the next century, with the uncertainties of maybe 2 feet, maybe 4, maybe 15 or 20. And my guess is that there's going to be a huge fight in the IPCC. A whole bunch of people are going to run models that give you 3 feet. And then we're going to say, but your models don't have these fast physics in that give you 15 or 20, and they'll say, yeah, that's true, but they won't happen. And then we'll have a big fight. The IPCC on sea level has basically gone physics models, and it's always been a big fight. And so what comes out next, we'll see. But the worst case is really bad. So there was one back here, and then, yeah, okay.
In the current fossil fuel economy, things like efficiency and conservation, wise land use planning, are things that we on the ground, as you talked about, are concerned with on a daily basis. Will that change with a renewable energy economy?
No, I think it's always going to be there. Probably it's going to be a more knowledge-based economy. As long as you have, really serious high-density energy in gas or coal or something, you've gotten by with being a little bit inefficient. This ability to take apart a mountain with a shovel. When have two daughters. The younger daughter, when she is now a grad student, when she was in middle school, she got us into the cab of a drag line at a strip line. She was doing a History Day film. And Cindy and I and the two girls we're at the strip line, we're in the cab, and the guy's miming. So there's this guy with two joysticks taking apart a mountain. It's just fantastic. And he said there's four of us running this thing 24/7. He said, we've got great jobs. And he says, this guy drives a truck, and there's a guy that sets the charges, and there's a guy that greases it. That's all the jobs. You know, there isn't anything more. But it's so concentrated, and he can do so much of it, that sort of being a little bit inefficient, they got by with it for a while. I think in the future, it's going to be more knowledge-based. If you've got a whole bunch of wind turbines or a whole bunch of solar cells, you're going to have a really good meteorology department here forecasting them for you on the minute-to-minute range to make sure you've got them tweaked just right. And that in turn is going to be jobs for people. And my understanding, you ask the economists, and they like to say all options are identical and nothing's different, just be efficient and ignore it. But there is some scholarship that says anything except fossil fuels gets more jobs. And in particular, you can get certain things we could do that it's pretty obvious. So the cheapest fossil fuel producers can probably, overseas, can probably put oil on a tanker and head it to you for about $5 a barrel. And you spend 45 or 50 or whatever it is today for that. And the $5 is jobs. Right? Somebody is guarding the pipeline or drilling the well or fixing the pump or something. And the rest, the economists call it rent, but the rest is just payment that they control a valuable resource. And it's not jobs. And they might hire people to work for them, and they might buy art, and they might buy camels, and they might buy bombs, and they might put them on a mattress. You have no control on what they do with that. If you put that into conservation, somebody comes out and puts window quilts on your windows, somebody's coming out and putting window quilts on your windows. And if you put it into a heat exchanger in the ground, somebody's doing that. And if you put it into putting solar cells on the roof, somebody's doing that. And there's jobs on all those. And so the scholarship tends to say that rather than paying rent, somebody controls a valuable resource. You pay for workers and knowledge as you move towards these renewables. Not much scholarship on that. If you know any economists who are interested in this in your departments, having them look more carefully at this and do the scholarship would be very interesting, because there isn't much scholarship. And all of you come from schools who have economists who might be interested.
I was surprised, even surprised, to learn that the IPCC models that 1984 didn't have a lot of the land sea feedbacks, and just starting to put them in there. I think that is the case. What's the magnitude of that problem? Okay, what's likely to happen to our projections of CO2 atmosphere to temperature if we start to
Right. So the question of the IPCC models lacking some of the feedbacks which are on the bad side. Cautiously optimistic that it's slow. So it's not, our decisions are still more important than those feedbacks, but with some slight chance that it's fast and bad. But it illustrates a general point, which is that the uncertainties in this are almost always on the bad side. So when you take an outcome from the IPCC on almost anything, and this includes the physical impacts, it includes the biological impacts, it includes the social, the economic, anything you can pick, they give you a most likely future. It may be a little better than that, it may be a little worse than that, and it may be a lot worse than that. And almost surely not a lot better. And you can ultimately get to that from some very commonsensical things, right? You can't make this with a hammer, but you can break this with a hammer. You can't make Eden by just cranking up CO2, but you might create things that you care about by cranking up CO2. CO2 is plant food. The plants grow better with CO2, but not a lot. And maybe they'll do a little better than we expect, and maybe they'll do a little worse. But if it gets too hot, your plants die. And if it gets too cold, they die. And if it gets too wet, they die. And if it gets too dry, they die. And if you no fertilizer, they die. My dad used to kill my mom's flowers by over-fertilizing them. If you get the invasive rust, they die. And if you get the invasive this, they die. And if you don't have the pollinators, you don't get the crop. And it's as bad as it, they die. And so we have considered the fertilizing effect of CO2 has been in every IPCC from the first one. And maybe it'll be a little better, and maybe it'll be a little worse, and maybe they'll die. And so you look at the uncertainties, and they tend to be weighted on the bad side. You look at sea level rise, and it's 3 feet, maybe 2, maybe 4, maybe 20. You look at, we were chatting earlier, I was at a meeting, and an economist, I asked the economist, what's your worst case scenario? And they said, well, the economic growth was cut in half. So what? That's the worst that you could possibly imagine happening in all history is that climate change cuts economic growth in half. Absolutely, that's the worst thing that could ever happen. Yeah.
Thank you, that was terrific. My question goes to the gender consequences of climate change. So the IPCC reports, some have remarked that they sort of underserve or underreport the gender consequences of climate change. The theory goes that with climate change it increases the propensity and the impact of conflict. And that conflict tends, not always, but tends to adversely affect women and children more than men. And I'm just wondering if you think that's because most of the researchers in this field have been men, or if there are other things going on. Thank you.
Yeah. I suspect you can speak to this better than I can. I suspect that what you just said in your question is actually accurate. The impacts are disproportionately on women and children. And it's partially because women and children. Okay? So if you're trying to take care of somebody, it is harder to be mobile, and it's harder to deal with changing conditions, and you need more resources more rapidly. And so I think that is accurate. And whether the IPCC has called that out as forcefully as they should is a good question. I think that probably later, I know Don is very interested in a number of these issues, and I believe either at coffee breaks or maybe more formally later, he's been working very hard to get a broader look at the ethical implications across many fields, and that would include gender equity. And this is, economically, it is clear that dealing with this can be helpful compared to ignoring it. But that is done under this structure that says our grandchildren are not as important as we are. If you start saying our grandchildren are as important as we are, and you start saying poor people in hot places are as important as we are, then you would take much more action now to deal with it. And so I have some slides in here somewhere that I can pull out on who is changing the climate and who is suffering now from the changing climate. And it's almost a mirror image. So whoever emits the most CO2 is suffering the least from the changing climate, and whoever emits the least CO2 is suffering the most right now. And so if you're interested in ethical issues, the economic, if you wanted to be economically efficient, you would deal with this. If you wanted to be ethically efficient, you would deal with it more. Yes?
So almost everybody in this room is really working to have their institutions live so that we can live well and teach our students to be able to do that. And to make our institutions a model for that, for our students to watch. I bet everybody here feels like that is such an uphill battle. Why is that such an uphill battle? Am I right?
I wish I knew. And it is partially, so I will offer a few observations, but I don't know, and maybe that's a lunch discussion. Partially, I do think it is because that every institution is trying to raise money, and some of that money comes from people who will tell you that we're evil liars. And others of it comes from people who actually sort of get it, but they're not terribly interested in doing something about it. So it is conceivable that is part of the story. I suspect that a lot of it comes from people who are convinced that in dealing with this, we are disrespecting some piece of our history, and we are disrespecting something that they have done. And I think that there we need to do a better job of communications. Oil was good. Oil is good. Most of you are going to drive home, and you probably will not do it on a completely electric car, and if you did, it would be cold around here. You're going to drive home on oil. And we have to thank them and recognize the good that was done, while at the same time seeing that the future is something else. I gave a talk once to a number of people working for the federal government. They were in fish and wildlife, and they were in parks. And eventually, one of those people said, "Look, I get everything you just told me, but you just killed the town that I grew up in. What do you tell them?" And I tried a whole bunch of things, and I can go through the things. What is killing now is gas. Gas is killing coal, not Obama. But and I finally said, "Look, you're sitting next to a ranger from the C&L Canal, and Washington went and lobbied the Continental Congress to put in improved waterways so they could bring goods from the booming West back to the East, which meant running them down the Potomac. And we built canals. And at some point, they took iron that came from these furnaces, and they put it on the canal boats, and they sent it, and they built railroads, and they put the canals out of business. Because the canal was never going to go across Utah. And they all knew it. And at some point, they said, look, the future is the future. And we can't actually say that we must keep the fuel driver on the canal. It's just not going to happen. And you go and you ask, what does the coal miners were heroes? But a whole lot of the art and the literature and the music is, I'm a hero so you don't have to. Daddy said, don't you ever be a miner, because a miner's grave is all you'll ever know. It was always, I'm doing this so you can do something better. And somehow it is, in betting on the future, we are not disrespecting the past, we are celebrating. And I think we need to do better at that. Sorry, I'm on the soapbox, I shouldn't be.
My question is sort of related to mitigate, adapt. So for those local folks, I'm a coastal scientist, spent a lot of time on the shoreline of Barrier Island, Ocean City, Maryland, and so on. So what do you do? How do you broach that subject? We have to get back online immediately following storms to be able to recoup the loss by getting our tourism dollar back. So at what point do we start to say, all right, we mitigate by doing X, and then here's why when we need to adapt and either abandon and move on? I mean, how do we broach those sorts of things?
Yeah, and it's very difficult. And of course, this business of the uncertainty being 2 feet, 3 feet, 4 feet, 20 feet, if West Antarctica collapses, we just have no idea what to do. And it's just terrifying. And I don't think there's any way we can plan for it. You can't plan for it. Nobody can plan for it. And it's within the realm of possibility now. Very clearly, as you know, even if we could completely stabilize sea level, Ocean City is sinking anyway because the ice age ended and it's still adjusting. So you have to adapt. There's just no question about it. There's no easy answers. I mean, this is where it takes the people like you figuring it out. A lot of it brilliant things of making the coast resilient, getting, you know, when everyone hates it when you put it in the public land, and once it's there, everyone loves it. Everyone hates it when you put in a bike trail, and then once it's there, it is in every single real estate ad from now on in eternity. So it is sort of finding those moments of saying, look, we're not retreating, we're moving when we put in a buffer zone. And then probably it is looking for those clever things, such as an offshore wind farm can be an energy sink for the hurricane, and an offshore turbine farm under the water can be an energy sink for the storm surge, and you're dropping the storm surge, you're taking energy out of the waves, you're taking energy out of the wind, and you're powering the coast. And, you know, those are not easy, and people don't want it in their vision yet. But there may be ways forward, but it's not easy. I'm sure you know way better both the problems and how to solve them than I do. Okay. And this again is where what you do, and it's where sort of the knowledge base and the people who are connected are so important. These problems will not solve themselves. They will not be solved by science because they're real people on the front lines dealing with real things. And there's no chance, even if we mitigate completely, we still have to adapt. Cutting off the worst of the future climate change is some climate change is still coming. Sea level will rise. And so we have to deal with those changes. The question is, how do we find those? There are places there will be win-wins. There are places that you will make work that you'll end up with a coast that actually works better. And there's places we will build a wall, we will declare that it's safe, we will build valuable things behind the wall will fail, and we will have screaming, hideous disasters. And how do we get fewer of those screaming, hideous disasters and more of the wins? You know, this is hard, and if people put their lives into doing it, we just have to celebrate that.
We have time for about one or two more questions, and then we'll take lunch. Anybody?